Yeah, and thank you everybody for joining. Obviously, Sam, for dedicating the time to do this. I know you're busy, and this is not the first time we've had you speak, so it's great to see you again. I am looking forward to this. It's actually a little different from some of the talks that we've had, at least in the workshops planned for these 2 days. So it'll be a nice switch up. I'm really excited for this one. And for those who are joining us perhaps for the first time at the event, we have these 2 days of workshops, and then we have 2 days on the conference platform, which is Hopin. So you will get an email with a very unique link to join Hopin today. Take a look for that. And then we have our event app as well, which you can join if you want to see who some of the other participants are, who some of the other attendees are, job openings, some discussions that are going on, and get an idea for what projects everybody's working on. There's lots of really interesting people there, so you can check that out as well. But alas, I don't want to take up too much of your time here, and I really want to introduce Sam for the folks who haven't had a chance to meet him in the past. Really extensive amount of experience, and he's got more accomplishments that I can mention in the short bio. But let me start by recently, I guess, introducing Sam. Recently, he has joined the technical leadership team at Facebook. From 2020 to 2021, Sam was IBM's Chief Technology Officer for AI. And from 2017 to 2020, Sam was the IBM Chief Technology Officer for Data, focusing on IBM's database and big data portfolio. He's the co-founder of IEEE's workshop on self-managing database systems. He has more than 65 patents issued and pending, and has authored 4 books and over 30 papers. Sam's books have been translated into Chinese, Japanese, and Spanish. And in his spare time, he's an avid guitar player and fencer. His Twitter handle is Sam Lightstone, and I'll put this in the chat. And if you have any questions throughout this session, feel free to shoot those in the chat. As Sam mentioned prior to us kicking this off, he's going to share the presentation, so we'll make sure you have that as well. And yeah, without further ado, I welcome Sam here.
Awesome, thank you, Dave. Pleasure to be back at Team LS, and I was here a few years ago. At the time, I was involved in a whole bunch of AI work at IBM, and Dave reached out to me this year and invited me to submit an abstract. And I thought, if I was at the conference, like, what would I want to hear about? So I chose this topic about AI benchmarking because I think this is a topic that if I were you guys, I would want to hear about. It's practical and it's different. It's different from the usual discussions on model efficiency, model types, AI ethics, and all the normal things that you hear at the AI conferences these days. So without any further ado, that's why I chose the topic. I'm glad that it was accepted, and thank you all for attending, and let's jump into it. And here we go. Okay, so the topic today is a platform that's called DynaBench. That's the benchmarking platform. You can find it at dynabench.org. It's an open source platform, so we welcome contributions from people all over the world at all different organizations. The platform itself is hosted on AWS. So even though many people at Facebook, which is now called Meta, many people at Meta were sort of founders of the open source project, it is by no means a Meta project. It's people all over the world working on it from many companies and universities. It's hosted on AWS and so on. And what this platform allows you to do is upload models and try them out on canonical data sets that are submitted by the community, on benchmarks that are defined by the community, and evaluate them on a range of attributes. And we think that this is actually very different from the benchmarking that's been done in the past for not only AI, but actually other domains of computer science and technology. And we think that it's at least on a path to solve some of the problems that sort of inherent in benchmarking, technology benchmarking over the last few decades. So let's jump into it. And I want to just go back a little bit in time and go through a little bit of the story arc, how we got here, and why this is germane right now. So we'll start with the beginning. 1945, end of the war, and the US Army creates the ENIAC computer. Here we are in the basement of the electrical engineering building at the University of Pennsylvania. And this is the ENIAC. And when people talk about computers that used to fill a room, that's the one. All right, filled up a whole room. And all it could really do was calculate trajectories for missile bombs, the trajectories for the bombs. They were doing so many bombing runs, they just couldn't calculate the mathematics fast enough by hand. So they built this thing. It was towards the end of the war. And it has the sort of claim to fame of being the original electronic computer. So that was 1945, and you can see there's no keyboard. The way you program this thing is just by pulling the wires out of sockets and putting them into other sockets, and that sets the flow of instructions. Fast forward 1 decade. And here we see this man, some of you may know of him, Arthur Samuel, research scientist at IBM in the 1950s. Now, the most sort of blatant thing that you see in this picture is the technological advancement. It's got reel-to-reel tapes, which means it's got memory. The computer fills up only half a room, not a whole room. And you see Arthur Samuel here with a checkerboard. I have no idea what they actually paid him for. But Arthur Samuel goes down in history as one of the seminal thinkers in machine learning and AI because he developed a computer system that would play checkers. And you may say, well, who cares about checkers? I had a computer game that played checkers when I was a kid. Like, of all the inconsequential, unimportant things that a computer could do, why does that matter? Well, it matters because he didn't want to just create a software system that could play checkers. He wanted to create a system that would learn from experience. Every time it played a game of checkers, it got a little better. And he would come in to work and play game after game of checkers with his AI system. And in 1959, he actually dubbed the phrase machine learning. If you're wondering where that term comes from, that's the guy, machine learning. A system that learns from experience. The more experience it has, the better its model becomes. In 1962, he pits his machine learning checkers game against a state regional champion, a guy by the name of Robert Neely, and the computer won. And probably nobody noticed at the time, but actually we can look back at it now and say, well, that's probably one of the most seminal events in the history of computers, that a machine learning system beat, sorry, let me turn off my phone here. The machine learning system beat a human expert in a game of strategy. So with that begins the domain of machine learning. And of course, lots of other seminal thinkers at the time, Marvin Minsky and so on, long list of names in those early days of the 50s and 60s. But the reason I mention this to you is that there's actually something very interesting about that period, which is when you look at this domain of artificial intelligence, machine learning, and deep learning, the overwhelming majority of these algorithms, which are at the heart of all of this, are actually developed in the 50s, 60s, and 70s, and a small number of them in the 1980s. So, and I'm sure at the conference, you'll hear all about these algorithms and models. And you look back at this through the story arc of history, you go, wow, like that's not high tech, that's old tech. That's like 1950s. And then from about the early 1980s, about sometime around 1984 until 2012, you really don't hear too much about AI. It's kind of dead. It's like the dark ages, there's frozen over. And then suddenly, a few years ago, there's a reawakening of this domain, which has led to this flurry of activity, which has brought us all here now to this conference. And what was that activity? Well, I want to suggest to you that a big part of that activity that has generated this resurgence, or at least one of the key ingredients, was benchmarking. There are three inflection points that brought us here. The first is the advent of big data. You see, in the 1950s, it's Arthur Samuel and his checkerboard. That's it. Like, there's no digital data. There's lots of data in the world, handwritten data, typewritten data, but digital data in a computer, not much. And as all of you who are at this conference know, machine learning requires a tremendous amount of digital data. The advent of big data, the late 1990s, early 2000s, the internet begins to assert itself, becomes commonplace. Every time you go on the web, you're generating data. Every time you swipe your credit card, you're generating data. And so suddenly we enter this era of big data in the early 2000s where we're swimming in data. And now we've got the digital data, we can begin feeding these algorithms. So this domain that was sort of mathematical and theoretical, but not practically useful, and during the 70s and 80s and most of the 90s, suddenly has data on which it can make itself useful. It can apply itself. And that's inflection point number one. Inflection point number two is the rise of powerful and low-cost compute. Now, most of us don't fully appreciate it, but I'll bet everybody on this call has a cell phone. You all own a cell phone. Probably looks like some variation of this. And your cell phone has more processing power than the supercomputer that beat Garry Kasparov in 1997 and filled up approximately half a room. I can't remember how many thousands of cores that thing had. But measured in processing power, gigaflops, billions of floating point operations per second, your phone is more powerful than a 1997 supercomputer. And today you can log on to a public cloud, Google Cloud, Amazon, Azure, IBM, pick your cloud, and you can lease, thousands of times the processing power of a phone for pennies, literally for pennies. And machine learning and AI is hungry for processing power. So it's hungry for data, it's hungry for processing power. And by the way, of course, we don't usually use CPUs for all this, we use GPUs, but that's sort of beside the point. We have power on tap, processing power on tap, and then we have lots of data to feed. And still you don't hear too much until one final seminal event in 2012, the ImageNet Challenge, which was started by Fei-Fei Liu at Stanford University. ImageNet Challenge was a competition to make it possible for algorithms to compete to do image classification. So in the ImageNet collection, there's an arbitrary collection of digital photos, and the challenge was, can your algorithm figure out what is in each of these photos? So that was a very exciting challenge and also a very difficult problem in computer science, and an extremely hard problem to make any progress on for obvious reasons, because to the computer it's just a bunch of dots. Until a seminal event in 2012. At the 2012 ImageNet Challenge, the research team out of University of Toronto, under the supervisory leadership of Geoffrey Hinton, submitted a new algorithm based on convolutional neural nets and achieved quite a dramatic step function improvement in the classification of images. And at that moment in 2012, whole industry woke up. Every computer science department in the world woke up and said, "Oh my God, what just happened? What did these guys just do?" And this area of computer science, which had really been pretty quiet from 1984 until 2012, suddenly woke up. And you have the perfect storm of big data, powerful compute, and benchmarking to tell us how we're actually doing. That suddenly reawakens the whole space. So here's an interesting plot of how these algorithms actually improved over time on the ImageNet Challenge. You can see that big 2012 event, roughly 40% improvement in the reduction in the error rate. But perhaps more curious than all of this is you see that red line that represents the error rate of a human interpreter of the images. And by 2015, the AI is already exceeding the performance of humans. Fascinating. And there's something very important in that for us to be sensitive to, which is that, of course, the AI is really not as good as humans at doing image classification. Lots of evidence of that. So why is it beating the benchmark if, in point of fact, it's not really better? Benchmarks do have a lot of value, and there's a long tradition of using them in computer science. ImageNet happens to be one that was famous for AI and image classification. Spec CPU, the whole spec organization, spec int, spec CPU for benchmarking processing efficiency, TPC organization for transaction processing, and analytics, complex query processing like TPCDS. These are famous. I'm sure there's lots more. Those are three that I happen to know and be familiar with. And these benchmarks allow us to actually measure how we're doing, and compete one approach against another, one piece of hardware against another, one algorithm against another. You can measure your own progress, you can measure your competitors, you can compare technologies. And when it comes time to market technologies, instead of marketing hype, you can begin to market actual facts, quantitative facts. This algorithm is 50% better than the other guys or whatever. So the benchmarking is incredibly useful, incredibly powerful, but it is fraught with problems. Now, at this moment in time, there's no better time, no more important time for us to start dealing with those problems. I'm going to talk about what the problems are in a minute, and I'm going to introduce you to the DynaBench technology. We're living in a moment where AI is going mainstream, and I think all of you at this conference know that. So I don't have to belabor the point about how it's being used everywhere: fraud detection, legal applications, medical imaging, you name it. It's everywhere. And so the time is now for us to get a handle on how we measure this, how we understand how effective these algorithms are one against the other. So let's talk about some of the problems in classical benchmarking, and then we'll see how the DynaBench technology hopes to address some of this. Here you can see a collection of AI benchmarks. ImageNet is one I've already mentioned, but there are others: Glue, Squad, Switchboard, you name it. And on this chart, like any chart, the most important thing to cast your eye on is the y-axis. This y-axis goes from -1 to 0.2. -1 is the normalization, showing the performance, in other words, the accuracy of these AI systems when they started. So we give them a common baseline of -1. 0.0 represents human performance on the benchmark. And what you see is that these benchmarks allowed algorithms to very, very rapidly improve and exceed human performance. Every one of these benchmarks is now performing at a rate better than human performance, which is fascinating. So like, there's a real competitive swell that happens. People get into it, and algorithms improve very rapidly because we can measure it. When you measure something, you can improve it. The problem is, one of the problems is, it's a little bit of a gamification exercise. The algorithms get really good at getting better and better at the data that's in the benchmark, but they're not necessarily good enough to handle the breadth and scope of what's in the real world. So you get this sort of long tail problem where the algorithm is super good at the narrow case, the case that's defined in the benchmark, but for the vast real world set of scenarios, they're still not very good, which is why they're far below human performance in actuality. That's one of the problems of benchmarking. Let's look at some of the others. Classically, a lot of the AI benchmarks that have existed, there are many of them. I've just mentioned 5 or 6 of them before. They mostly focus on accuracy. How accurate is the predictive power of the model? Here you can see a recent benchmark from the Superglue leaderboard. It's all about accuracy against the collection of data sets. Here's an older leaderboard from Superglue, same thing, all about accuracy. Here's another one from Squad. Here they have 2 metrics that they track, EM and F1. EM is all about exact match. F1 is about accuracy. These are basically 2 different flavors of accuracy that they're measuring. Again, it's accuracy, accuracy, and more accuracy on a narrow set, a narrow domain of data. And here, finally, you can see the ImageNet challenge. And this one's a little bit different. It's accuracy, but it's also showing the number of parameters in that third, sort of 4th column from the left. So that's a slight improvement, but basically just showing overwhelmingly, all of these benchmarks are focused overwhelmingly on accuracy. And so if you stand back from all this, you'll see there's a whole bunch of problems in benchmarking today of AI. There's a saturation problem that the algorithms sort of compete on a narrow domain, and they get so good they're better than the humans, but it doesn't mean much after a while, because it's just a bunch of benchmark specials where they get better and better on a particular narrow domain, and they're still horrible at the general case. There's no measure of bias. Bias creeps into these algorithms from overfitting, or bias against actual human beings, bias against age, race, religion, ethnicity, etc. You don't want that in your algorithms, but we're not measuring it today. I mentioned the alignment problem, that they're not broad enough to really deal with the real world issues. The leaderboard culture of just trying to get your algorithm at the top, regardless of how much you're really just special casing the narrow domain. Then from a research perspective, we get into some very interesting problems. Going to that bottom left, reproducibility. People often publish papers saying my algorithm is better than the other guys. Can you trust him? I mean, even if he meant well, can you trust him that he reproduced the other guy's algorithm authentically and it was properly tuned and so on? Accessibility. Someone says, I developed a great new algorithm. Can you get your hands on it? Sometimes they publish it on Git, often not. How about backwards compatibility? Someone creates a new model. You want to try it out on a new data set that wasn't yet published at the time they ran their experiments. So there's all these problems. And what we're hoping to do with DynaBench is address many of them. So nobody really has all the answers to these questions, but we think part of the answer are the things that we're working on here in DynaBench to support multiple tasks over multiple rounds, make this an iterative process, to make it a community effort so that people can dynamically compare their models against data sets that are uploaded by the community. To have a dynamic leaderboard where you can test against multiple attributes, not just the accuracy, but all other attributes like performance, footprint, bias, etc. And to do this all in the cloud, so it's really easy, it's centralized, and everybody's running on the same hardware. There's no doubts or debates or trying to extrapolate from the CPU of 2 years ago to the CPU or the GPU of today. And we think we can go a long way with this. So this is what DynaBench is trying to tackle, to give that centralized cloud platform in open source that all of us can use collectively. So let's jump into what this looks like. A task owner can define a task on DynaBench. And a task is, think of a task as essentially a kind of benchmark. So sentiment analysis or image classification, those could be examples of two different tasks. So a person will define a task for everyone to compete on. That's person number one. Person number two is the person who builds models. So maybe the task owner created a new task for image classification, and the model builder builds their model for image classification and wants to try it out. They can create a model and upload it for that task. Then we can have model users who interact with these models dynamically. And finally, we have the breakers, people who want to try to break the models or dynamically interact with the models, see if they can create counterfactual tests and so on. All of this can be done on DynaBench, and it's a cloud service, completely open source. So you can do all this dynamically, uploading models at any point in the day and have them instantly evaluated against all the data sets that have been uploaded. Now, a key idea here is that it's not just about accuracy. Again, accuracy is good, but it has limitations that we described. There's overfitting problems and so on. And there are many other things that are important in benchmarking aside from accuracy. Fairness is an important one. You don't want to be biased against human beings. Robustness, how robust is the algorithm to new data? Throughput, how performant is it? How much memory is it using? Sort of the green qualities. What's the carbon footprint of this model to train it and to run it? We believe that these are examples of other attributes that are worthy of benchmarking. And these are actually, all of these today are to some extent in the platform. Now, another interesting question comes up. Okay, so you say, okay, it's not only about accuracy, fine. But then if it's about 5 or 6 different attributes, how do you combine them? Who's to say which is the most important? So this is an interesting problem that a bunch of research went into, and we came up with this idea of DynaScore. DynaScore is the sort of aggregation of all these attributes into a single score. How do I know is my, when I put together all this stuff, power consumption, model size, yada, yada, how do I know whose algorithm is best? And it's a difficult question. How are you going to decide what the weighting of these things should be? So to solve this problem, the researchers who worked on this, not me, but people smarter than me, got together and they drew on an idea from economics and how economists exchange value between goods and services. And they use this idea of average marginal rate of substitution, which is the degree to which people are willing to trade off value in one domain versus another domain to achieve a 1-point increase in performance. And so the platform automatically calculates this AMRS and determines the starting weight of all of these attributes. Now, as a user of the platform, you may say, well, that's nice, but I'm more interested in the green qualities, or I'm more interested in throughput. You may have a different opinion. So to address that very common desire, we have the starting weights that we begin with, calculated sort of this economic model, and then we provide you sliders that allow you to personally adjust your own interest in how much to weight different things. Maybe you want accuracy to be the only thing that counts, or maybe you want it sort of 50-50 with model size, for example. So we give you the ability to adjust that. And I'm going to show you some examples of that. All right, so now we've talked about, that's all the background. Let's jump into a demo now of DynaBench. So this is, I know this is a bit of a preamble here, but now we're going to see this thing in action. Here's the landing page for DynaBench. And if you want to use this thing, you arrive on this landing page, and the first thing you're going to do is select one of the tasks, in other words, one of the benchmarks that you're interested in. So here you can see a set that are available: natural language, sentiment analysis, hate speech, question answering, and so on. So you click on the one that you're interested in, and that will bring you to that task page. Let's click on sentiment analysis here. And the next thing you may want to do is upload your own model. So we'll click on that Submit Models button. And this will bring you to a page that gives you all the instructions you need for how you upload your own model. It's a pretty simple process. There's a wrapper that you can download, that you wrap your model in, and then you upload the model. After you've uploaded the model, you can define some attributes of your model and publish it, and then you're good to go. So this is going by pretty quickly, but actually it's a pretty simple process. In about 10 lines of code, you can upload a Hugging Face model. Pretty simple. Once the model's been uploaded and published, first of all, you can begin immediately interacting with it. In this case, it's sentiment analysis, so I can type in a text here dynamically and see how the model fares on the text that I type in. In this case, we weren't able to trick the model. The model can tell whether we're entering something that's positive or negative sentiment. And the model's automatically scored against all the other models that have been uploaded for that benchmark. You can see here the attributes, the F1, throughput, memory, fairness, robustness, and finally, all of those are weighted together into the DynaScore. And if you click on the slider bar on the top right, you'll be able to actually adjust the weights of each of these attributes. So you have the weights that we determined through the economic model, but now with the sliders, we can adjust them. We can slide the weight of accuracy up and down, for example. And you can also do a very similar thing by adjusting the weights of the data sets. You may want to treat some data sets as being more important than others, for example. So you can adjust those. And you see the DynaScore is automatically adapted, and the leaderboard is automatically adapted as we do that. So it's pretty amazing how fast this all is. It's like every time someone uploads a new model or someone uploads new data, all these models are instantly reevaluated, rescored, the leaderboard is instantly recomputed. All right. So again, the secret to all this is you take your model and you use this wrapper that's found in the DynaLab repository on GitHub. You wrap your model, it's about 10 lines of code, and then you're ready to upload your model and you're off to the races. Now, the big new thing that we've introduced fairly recently, really just a few weeks ago, is this feature called DynaTask. Until a couple months ago, this benchmarking environment really allowed you to engage with the tasks that had already been defined by the administrators of the platform. And there's, there's a set of them there that you just saw, but 5 of them. What we've just introduced is this interface, this feature called DynaTask, where anybody can submit a proposal for defining a new task, in other words, a new benchmark stream on the platform. So what I'm going to show you a demo of how this works. But you can define your own task. Once you've defined your own task, you're off to the races. You can have your own leaderboard, upload models, invite your friends and family to upload their own models and data sets, and start your own dynamic benchmarking. All right, so now let's have a look at this DynaTask in action. So again, we'll start with the going to the landing page of DynaBench. And the first thing that we're going to do is we're going to go up to the top right corner and click on our profile. When we click on that profile, it's going to bring us to an option to create a new task. All right, let's go up there to the top corner. Here we go. All right, so in this case, we'll go there. We'll click on creating a new task. I don't yet have a task, so I'm going to propose a new task. I'll fill in some descriptions here. In this case, let's create a new task for sentiment analysis. And we will submit this to the platform. And basically what's going to happen is after this is submitted, it goes to a set of administrators who evaluate it. And within a couple of days, they get back to you and say, your task has been approved. And then you are ready to start filling in the details of your task and making it go live. So it's a pretty simple process. To fill in the details, you go to the settings page, and you're going to fill in this sort of JSON script. It's really not very cumbersome, about 30, 40 lines of JSON, where you describe the inputs and the outputs of your model. And lots of examples of this that you can follow. So in this case, we're doing sentiment analysis. So the input is going to be a string, and the outputs are going to be labels negative, positive, or neutral. You're just describing semantically what this model is going to do. And once you're finished with all that, you're going to save this. And literally, that's about as hard as it gets. And your task will go live. You can immediately begin uploading models and scoring. All right, so now the task has been created here. We have our sentiment analysis task, and we can begin interacting with it. Let's create some examples by just typing in some text. Again, it's sort of instantaneous. You uploaded, you created the task, and now you're ready to start already creating data examples. So in this example, we want to see if we want to create an example of positive sentiment analysis. So we put in a positive movie review. This movie was great. And we're now beginning to populate the data sets for this environment. Now you can do this interactively, or you can upload data sets. Both are possible. Another great thing that the environment allows you to do is to try to essentially break the models or beat the models by trying to submit data that fools the model, or sort of forces the model to have an incorrect output. And through this, the people who create the models can find this data and improve their model accuracy. So here's an example where we want to try to fool the model. Let's say we want to enter a positive statement that fools the model. It will say either negative or neutral. We'll say this model is great. Did we fool the model? Absolutely not. It was positive sentiment, and the model correctly determined it was a positive sentiment. But if we had fooled the model, it would have been really powerful and useful data for model builders and creators to download and retrain their data sets on. Okay, so those are some examples of how to create your own task. It's pretty lickety-split. The only real waiting is to wait for the administrators to approve your proposal, which usually is a couple days. So it's a bit of an introduction to DynaBench and the new feature of it called DynaTask that allows you to create your own benchmarks. It's a scalable platform. It's open source. The leaderboard is totally dynamic. Every time there's a new data set, every time you upload a model, everything is instantly rescored. We have this sort of brave new idea of scoring not only on accuracy, but on other attributes, and aggregating them through an economic model that we call DynaScore, as well as giving you the ability to dynamically select the weights on these things. So now is a place where everybody can go and do this and share as a community. It's not controlled by any one company. And it's really a great opportunity to take benchmarking to the next level. Just to give you a sense of the participation that goes so far, it's a pretty new platform, really just under development for the last couple of years. We've already got these 5 tasks: hate speech, question answering, natural language, sentiment analysis, and visual question answering on images. It's been used in a large AI competition. We have hundreds of models that have been uploaded to the platform already, and literally over 400,000 human-in-the-loop interactions where people are trying to use these models or beat the models, fake the models, and so on. So it's really gaining a lot in popularity. The research activity on this is actually quite breathtaking. You can see a list of related papers just in 2021. These 13 papers, all just in 2021. It's pretty amazing. And there's a whole bunch from 2020 as well that are not listed here. So it's a very active research space to figure out how to best do this. Again, I encourage all of you to get involved. I said from the beginning, this is not just a Facebook initiative or a Meta initiative. Lots of other groups getting involved. So on the left-hand side, you see the names of some of the key people who have been involved in the development and research of this. On the right-hand side, you can see some of the organizations. Notable in this is ML Commons, which is a consortium of many companies. And you can see Meta, of course, involved, and a lot of universities. And this list is growing pretty much every few weeks. There's another icon going on this. So all that is my sort of preamble to all of you, which is now's a great opportunity not only to use this platform, but get involved as a contributor, contribute models, create your own new tasks, help improve the code base because it's open source. And really, I'd love to see all of your companies get your icons up on the slide on the right-hand side. Be good for you and be good for the community. And everybody wins with stuff like this. Just to wrap up, I wanted to share with you some links that you might find useful. Again, the DynaBench webpage itself, dynabench.org. Feel free to check it out. Really simple interface. Some other links related to Meta, the new company name for Facebook. AI research blog is fascinating. You may find that interesting. The analytics blog, operational data blog, and finally the virtual reality research and publications. All of those fascinating stuff that you may enjoy, you're welcome to and encouraged to go check it out. And finally, maybe a little bit off topic, but I can't resist. I'll keep it short. I just want to make a quick plug for jobs. We're hiring like crazy at Meta, and we're hiring in all the areas that many of you work in. So AI and data science, yes. Virtual reality, data warehousing and analytics, and operational data systems. Tons of jobs in Toronto, and even many of the jobs that are elsewhere in the world, in California and Seattle, Boston. Actually, a lot of times, if you tell them that you'd like to work in Toronto, they'll be happy to let you work remotely from Toronto. So tons of opportunities. Check it out if you're interested. With that, I know I went through it all somewhat quickly, but thank you for joining. I hope it's been interesting. And I think we can open it up for a few questions.
Sam, we have one question here from Yusra. The question is, what is fairness based off? Is it intended for use against non-NLP models?
Right. So right now, the focus of DynaBench in this first, say, year and a half has been overwhelmingly on natural language processing. They just added the image processing task. It's pretty new. I don't know exactly when they added it. I suspect in the last 2 months. So all the fairness stuff right now is text-based.
Thank you. I have a quick question, Sam. Can you talk a little bit about where this was based from? Was this sort of a consortium of folks working in the field that said, hey, this is something that we would really benefit from? Or can you talk a little bit of as to the origins of this idea as a concept in this project?
Yeah, great question. The truth is, I don't know all the details of it. I'm happy to look into it for you. I can tell you what I do know, which is that you know, if you look at the publications, scientific publications around AI, you'll see that there are really 2 companies in the world that dominate the research. I'm not talking about products, I'm talking about research. Seminal research on AI is dominated by 2 companies, Google and Facebook. And a lot of the work that Google is doing is to optimize their ads work and some work on image processing. But, you know, really, nobody competes with Facebook on breadth. You know, in terms of the range of problems that the company is looking at to try to make the internet a safer place, even though you may hear hype and arguments in the press to the contrary. The fact of the matter is that Facebook invests billions of dollars every year, certainly in 2021, billions of dollars, to make the internet and its platforms safer, and more efficient for everyone. To do that, the company is operating at massive scale. I mean, billions of dollars just in this domain of better AI to make a better world, operating on exabytes of data in well over a dozen data centers globally. And so I think the attitude at Facebook is that this is goodness for the world. And so Facebook really was the company that started all of this, this DynaBench initiative. And from there it grew because researchers and companies alike see that this is in the greater social interest of the community, and it's great research as well. And if you're a researcher, you want to get involved in this. You want to have a place to evaluate your models. You want to have a place to see, to compete. You want to be able to do it easily. This is like 100 million times easier than the old ways of doing benchmarking, where everybody had different hardware and you can't get a hold of the other guy's model and what data did he use and how do you compete. This is like 1 million times easier. So it grew out of an initial need at Facebook, and from there is just catching on because it's sort of an obvious winner.
Sam, can you see in the chat there? There's a couple questions.
Let me see if I can open up the chat.
Otherwise, I'll read them out.
How does DynaScore correlate to the end application? Excellent question. So again, the way DynaScore works, you have multiple attributes, fairness, robustness, accuracy, model size, and it creates this economic model for which one should be more important. But the interesting question is, that's being asked here is, how does it relate to the end application? And that's exactly the point that we were on, that it may not. By default, it may not. Your end application may care more about fairness than the DynaScore originally gave it a weighting for. And so to address that, that's why we have these dynamic sliders that you can say, look, for my application, fairness is more important, or it's at least, it's more important than you gave it credit for. Or model size, power consumption is more important than you gave it credit for. I want to change the weighting of those things. And so you can create your own utility function by swizzling the sliders to really make it match what you believe the application should care about. And what may come from that is you may find out that your model, which it has a certain score by default, but after you swizzle the weighting, you may say, look, for my real world application needs, my model actually does better than the original DynaScore thought it would, because I care more about some of these other attributes, I care less about some other ones. So that's why we put it in your control, that you can adjust these sliders to make it match your real world environment, what matters to you. All we're trying to do with the default is come up with a sensible way of rationalizing what the default weighting should be by looking at how people appear from the data to be putting their energies into. I hope that answers your question, but again, we're trying to figure out, the default is based on what appears to be important to people from what they're uploading, and the sliders let you tune it to what you believe should be important. Okay, some other questions here. Question about adversarial data being generated. Large scale application or just the research domain for testing? Okay, excellent. So basically let me dwell a bit more on this idea of the data that's used in the benchmark. There are two kinds of data. There's the data that people upload. People upload data sets, and those uploaded data sets are used for the actual scoring. Then in addition to that, you can have users who just walk up to the system and start interacting with the models. And those interactions aren't by default part of the scoring per se, but they're all stored. We store every one of those interactions. Every time you walk up to the system and you type something in against one of the tasks, we score it. So we save it. And then you can download all those interactions and retrain your model. So you may say, oh, look, there's been 1,000 people typing in all kinds of interesting interactions. Maybe they fooled my model 50% of the time. I want to download those interactions, retrain my model, and my model will now be a more powerful, more generic model as a result of that. So the counterfactuals are not auto-generated. They're generated by human beings interacting with the system. But what's great about it is people interacting all over the world And then you, as the model uploader, you can download those interactions and retrain your model, and then upload your revised model back into DynaBench. The question about, does it mean that the subjective parameters such as fairness and bias are being sensibly given an element of objectivity using DynaBench? That's the intention of DynaScore, using this economic model. That's the intention. Whether it's successful or not, I think is maybe a little too early to tell, but that is the intention using this economic model. Next question was, can you talk about the pros and cons of using adversarial models to generate synthetic data to fool the model versus using user-generated data? Does DynaBench have this capability? So right now, DynaBench is using just the human in the loop interaction. It is an ongoing question about whether it should be using adversarial models to generate synthetic data. And I actually discussed that with the research team sometime last week. And they think it's a great idea, but it's just not something that they've done yet. So, again, it's open source. This is a great opportunity for researchers and data scientists to get involved. This would be a great augmentation, I think, to the platform. But at the moment, it's purely human in the loop. Whether it's useful, I think it's very useful. Anytime you can automate something, you can take technology to the next level. It's good to have both, but automation is a fantastic idea. So I like the idea very much of synthetic data to create adversarial data sets. Awesome. So listen, guys, I'll create a version of this deck that's available to everyone. I'll send that around sometime today. Hope you found this useful, and I really encourage you to check out the site DynaBench and get involved. I think it's going to be win-win-win for everybody in the industry. It's just for researchers, for practitioners. There's very little downside to this idea. So thank you very much for tuning in.
Thank you so much, Sam. I really appreciate that. And if anybody wants to get a hold or ask you any questions or follow up, can they, do you advise that they get in touch via the Twitter link that you had mentioned earlier?
Yeah, and LinkedIn actually is an even better way to reach me. So sure. Sam Lightstone. There's only one Sam Lightstone at Facebook. So I'd love to connect with all of you. Ping me there. I check it pretty often. I don't check Twitter nearly as much actually anymore. So LinkedIn is preferred.
Perfect. Thank you so much, Sam. And thanks everybody for joining. We'll see you guys again for the other workshops. I think there's another set of workshops this afternoon, as well as a full day again tomorrow before we see you on the Hopin platform for Wednesday and Thursday. Thanks everybody. And thank you so much, Sam. I really appreciate it.
Good to see everybody. Thank you.